I'm Naygam from EC department in the PSN College of Engineering and Technology. Now we are discussing about embedded system and structural units in processor and how embedded system is related to artificial intelligence. An embedded system is an electronic system that has software and embedded in a compiler window. Depending on the application, it's a programming methods or non-programming methods are depending on the application. A system is working and organizing or doing any one of a particular task according to a fixed plan of a program or set of rules. In a application oriented, each processor can vary upon depending on the applications. A system is also an arrangement in which all its units and assemble working together according to the plan or program. In a working together on a plan or may vary between the processor and its requirements. This is an embedded system basic examples. Embedded system is basic is known as a particular application oriented. Watch can be operated as a seeing the time on the watch only. It's a time display system, parts, hardware, needles, and a battery, dial, and chases and traps. And its rules are very simple. It's a needleless moves clockwise only. A short needle rotates every hour, so human has easily adapt to this mechanical watches. A washing machine is a basic example for embedded system because it's oriented upon the status display panel, so it can view the how our dress can be display on this washing machine and running on this washing machine, and its switches can be viewed by the human beings, and dials, motors, and power display and its control unit. Inner water level sensor can handle the rotation of the waters and how it insert to the machine and how regulate this operation and solenoid valves, etc. These are the basic definition for embedded system. Without a human, it is a basic hardware system by human beings to give the intelligence to the hardware board. Okay, in a software program, we include the basic intelligence to the hardware board. So it is an embedded system. It's a one that has computer hardware and with the software embedded in it, and it's one of its important components. Each our program has stored in a flash memory. It's an internal storage RAM, and this program has been imported to the particular hardware processor. Okay, then its control unit has processed this instruction. Based on the instruction, the final output can be changed. Okay, the inter orientation can be run in a decimal, hexadecimal, binary values in it. Then a processor. A processor is the heart of the embedded system. An embedded system is a microprocessor that can be used in an embedded system. In a control unit, you have to segregate it into two parts. One is fetch and execute. Fetch instruction can be run in memory. Each instruction has its own data, and data can be fetched from the memory or a RAM and execute that instruction in the CPU processor. This is a basic differentiation between the microprocessor and the microcontroller. A microprocessor is a standalone system. It is designed as a way of working by each of individual itself. Okay, it's a standalone system. RAM, ROM, input, output, and the timer are separate. And the microcontroller, CPU, RAM, ROM, input, output, and the timer are all in a single chip. It's a microprocessor has a designer can design any amount of RAM row and input outputs. It's a specific application oriented. If a system has records more number of input output ports, you have to stick with microprocessor. If a particular general input output ports can be placed in a microcontroller, you have to fetch only 3 to 4 pins. Then you go with microcontroller. In a microprocessor, it's a high processing power and high power consumption. It's a typically 32 to 64 bits and is reliable. Example 80, 86 and 80, 85. And the microcontroller, it's a low processing power, low power consumption. It's a 8 or 16 bit controller. It's a single purpose control oriented basis and is highly reliable, and it's a basic example is 80, 81. Nowadays it vary in Ryzen, Atmeha. These are the basic examples in microcontroller. These are the nowadays it includes I square C, UART. These are the things in a particular microcontroller. So it has to need not require any interfaces sources, etc. It's a basic structures. It's a general purpose microcontroller system itself. In a B section, it's a microcontroller. All CPU, RAM, ROM, input output port, timer, and the serial COM port in a particular single chip. In a general purpose, each RAM, ROM, input output timer, and the serial COM can be separate. Each will be connected through the data bus or address bus. This is a layout model. First is embedded system environment, then is a human and physical systems. In an environmental, it's an embedded system. Embedded system has involved in a microcontroller or a microprocessor. It is depending on the various application. Okay. Through the information by the sensor, it operates into the particular stages. It's a human and physical system. It plays in the environmental systems. It collects the sensor collects the data from the environment, and through the data it sends to the transmit to the control unit, and the processor has used that data, and it gives a required output by the designers. This is a few examples of embedded system. It's a TV, washing machine, as I had told, washing machine, and phones, iPads, MP3 players. These are the cars. Are in a particular car, there is a lot of embedded systems in it. It's a artificial or automated system in it. It's in a car. It collects the DVD players, voice recognition, GPS, audio systems, and human vision, and a night radio, adaptive cues, and control and collision monitoring, and tire pressure monitoring system, display systems, instrument cluster, gaming controls, park reverse assist. These are the particular examples for the embedded system. As I already told, it's a hardware system. In the hardware, the particular processors in it, it's a processor, timers, intercontroller, I/O devices, memories, and ports, and etc. The basic high quality is a real-time operating system. Each instruction can be each instruction can be executed in a particular time schedule. Okay, it's a task schedule. It's another name is task schedule. Each operation will be scheduling and running into the particular timing. It's a real-time operating system. Then only it is called the real-time operating system. Embedded system hardware. Embedded system hardware. Before going into this, we must know this intro. First is BAS. First one is BAS, bus interfacing unit. It's in bus interfacing unit, we collect the external environment using interfaces. You interface the I square C or U what through this interfaces. We collect the address and data instruction data through the bus and collect from the memory address register and memory data register. Okay, address can be collected from the memory address register. Data will be collected from the memory data register and store it into the memory. Okay, then these instruction can be taken to the processor. Firstly, it loads the memory. If an instruction need, the stack pointer will be get those instruction and put it into the instruction data and execute that data to the processor. Okay, it's a system application specific circuit. It needs more data in a particular memories and access those memories between them. Okay, it's a input devices interfacing driver circuits, processor, timers, interrupt controller, output interfacing a driver circuits. It's a parallel port serial communication. In serial communication we use a Wi-Fi serial communication and the basic processor like I square C. These are the serial communication ports. Output driver circuits will be, yeah, graphics based outputs. These are process will be more only request power supply, reset pins and oscillator to increase the speed of the particular operation. It's a slow processing operation. These are the block description of the system. First, as I already told, sensor collect the electrical signals, then it's sent to the control unit. Control unit can be processed according to those instructions and send the final output to the actuator. And the actuator has done the mechanical operation or a digital operation according to that particular application. Features of the embedded system. It's a single function, tightly constrained and reactive and real times. Okay, in a single function, execute a single program repeatedly. Okay, in a tightly constrained, low cost, low power, and smaller and fast, life threatening, and the reactive and real time continually request to the changes of the system environment must compute certain results in a real time without delay. In the future of embedded system, in the basic itself, it's related to the AI process. It's an artificial intelligence. Through this AI, it automatically sends the data to the particular sectors. Particular data and according to data it will be execute the particular instructions. Now the examples of the embedded process is a house of 40 to 50 approximation and the process in the modern car is 50 to 60 oriented. These are the basic embedded processors will be used in the particular applications. And the languages for the programming for embedded system is assembly languages. Embedded C will be using. Nowadays, it's more languages like C, C++, ADA, Forth, and Java together with this new enhancement to the J2ME. The majority of the software for embedded system is still done in C languages. Like I already told in the embedded C. Nowadays, with a combination of Python and C to create a automation in a embedded system. In a recent survey indicates that approximately 45 percentage of the embedded software is still beginning done in C languages only, and the C++ is also increasing in presence in the embedded system, as the C++ is based on C language, thus the providing programmer the object-oriented methodologies to reap the benefits of such of an approach. Okay, you must firstly learn about the embedded C. Using in embedded C, basic structure will be all data will be depending on the one particular memory register. Each register and the processor or controller pins, it plays a major roles. Which pin has actively working and which pin are minimized. Depending on this, depending on those, it will be more effective. And C is a very close to assembly programming, and it allows a very easy process to underlying hardware, and the C++ is theoretically more efficient than C, but some of the compilers have bugged due to the huge size of the languages. In a software drive process, firstly you create a particular application process like project creation as a target device and select and configure the tool setting. Then according to the application, you create you create a course, you create a source code according to the application, which program will be executed in a particular time, and which execution, which instruction will be executed in a particular time, and this instruction has go with the plan of uh, go with the plan of according to the conditions. You create a source file, then only create a assembler C, and it works with the environment, real-time operating system and application build up of using the project management. After that, you create, you compile it, and if you rectify the error correction repeatedly to the source file, then after correction, we create a testing after the linking. Each process will be testing through its requirements. First then first only you recognize first requirements, application requirements, then planning, and then architecture, then particular flow planning as a, it's like a flow planning like power consumption, energy management, power resources. These are the management will be taken in the flow planning. How much time, how much delay this processor will be produced. Then only testing. These processes will be repeated in multiple ways. These are the structures. Okay. Then the classification of embedded system. Types of embedded system will be based on the performance and functional requirements, as I already tell, and based on the performance of the microcontroller. In your functional requirements, real-time, standalone, network, and mobile. In a performance of the microcontroller, small scale, medium scale, and the sophisticated. Okay, real-time operating system will be depending on the possible way of low size resources. Okay, and the standalone will be works among itself, and the network will be it's a system management, and the mobile will be like a Wi-Fi management. Okay, it's categorized in the standalone devices. It's a embedded system working by itself, and the Windows to the host systems. Okay, real-time systems, embedded system in which some of the specific work has to be done in a specific time period are called real-time system. In real-time, embedded systems are classified into two types, such as software and hardware real-time systems. These are the real-time systems examples like missile embedded with tracking system, and the aircraft, and the soft real-time will be a DVD player. In a standalone system, it does not require a host system like a computer. It works by itself. It takes the input from the input ports, either analog or digital, and processes and calculates the converted the data and gives the resulting data through the connected device, which either controls, drives, and displays the connected devices. Examples: MP3 player, digital cameras, and video games, consoles, microwave ovens, and temperature measurements, and controlling devices. In the MP3 players, the digital and cameras in your video games. First, you have to know about two things. One is data pre-processing and the data features. Okay, in a pre-processing, you have to collect various type of data like images are data points. Images are data points and a particular instance data. This like that. Okay, and in a particular sectors, you have to filter out the particular data and execute data in a particular processor like embedded systems. Okay, these are the basic players operating working condition. In a digital cameras, you pick the particular images and send it to the particular processes. According to the processes, it receives the values measurement of the images. Okay, then video games like etc. A network embedded system. These systems of embedded systems are related to the network to access the resources. The connected network can be LAN or wireless area network, etc. In a small scale embedded system is a single 8-bit or 16-bit microcontroller. It's a little hardware and software complexity, and they have even the battery operator. Usually, C is used for developing these systems, and the need to limit power dissipation when a system is running continuously. Its example is digital watches. In the programming tools are editor, assembler, and cross assembler units. In a medium scale embedded system, it's a singular few or 16 or 32-bit microcontroller or digital signal processing or reduced instruction set computers, both hardware and the software complexity. And its examples iPads and the programming tools are C, C++, Java, RTOS. RTOS is nothing but real-time operating system, and the source code, engineering tools and simulator, debugger, and integrated development environment. And is finally sophisticated embedded system. It uses more than 32-bit microcontroller. It enormous hardware and software complexity. For this system may not be readily available at the reasonable cost or may available at to the compiler might have to be developed for this speed available and constrained by the processing speed available in their hardware units. Example, it's washing machine. Washing machine is a sophisticated embedded systems. An embedded system constrains an embedded system is a software designed to keep in view their constraints, available system memory and available processor speed, the need to limit the power dissipation in a multiple cycle system in a particular variant of interrupt latency. And then finally application. These are household appliances, microwave ovens, television and DVD players and recorders. Audio players will be a MP3 player like a single oriented purpose plays an integrated system in a aircraft and missiles and cellular phones, cellular telephones, and electric and electronic motor controllers, engine controllers in automobiles and calculators, medical equipments in video games, and digital musical instruments and etc. These are the references I have to given to the viewers. You have to search on it, and thank you. Before going into this, one last display